everyone. My name is Kafero Gabdel and I study from Carlos Senior Secondary School, Form 2-1. So today I'm here with you to share just a simple practical of water. And as you know, water is this is the substance that contains hydrogen and oxygen gases. So for today we have to determine the boiling point of water. But before we determine the boiling point of water, we all know the freezing point of water. That the freezing point of water is 0 degrees Celsius and as well as it's 32 degrees Fahrenheit. But for the boiling point of water, it is 100 degrees Celsius or it's 212 degrees Fahrenheit. So today I'm here to share with you the experiment on how can we determine the boiling point of water. So before we determine the boiling point of water, there are some instruments in front of me or apparatus, let me say. So I have a Bunsen burner here. This will be my source of heat. I have a tripod stand that will help me to hold this other apparatus. I have the wire balls. I've got the beaker. I've got this is a thermometer that will help me to measure or to get the accurate or to determine the boiling point of water, because it's labeled. It has some measurements, as you see, from 0 to 100 degrees Celsius. I have my retort stand here that's holding my thermometer. So I also have a matchbox that will provide some source of heat to the burner. So as I begin, I need to first light my burner and I place it below the tripod stand such that the water begins to heat. Yeah. So as I told you that the freezing point of water is 0 degrees Celsius or it's 32 degrees Fahrenheit. Yeah, that's the freezing point. So the boiling point is 100 degrees Celsius or 212 degrees Fahrenheit. So as I begin here, we need a matchbox here, as I told you. So I will light my matchbox. So when I light my matchbox here, I need to place it below our tripod stand. So as I light it here, remember this matchbox provides the source of heat. This matchbox provides the source of heat to our burner. So after lighting it, the next thing to do is to place this burner below our tripod stand such that we can get the source of heat to our water that's going to be measured its boiling point. So I place here my beaker below the burner. So as you see here, the measurements that are indicated. Remember this red liquid, it's a mercury and it can be used in the thermometer. We have two liquids. We have a mercury and alcohol that can be used in the thermometer. So some people, they may ask, why in all liquids, why do we choose mercury? Yeah, so we have some characteristics of mercury or why mercury is used in the thermometer. So one of them is this mercury expands uniformly. It's not like other liquids, yeah, because you get some other liquids and you place them into a narrow tube, then you pull, yeah. So you see that mercury won't expand uniformly. It will leave some dots behind, yeah, some marks of it. But this mercury, remember, it expands uniformly. It doesn't leave any particle of it behind, yeah. So as you see, we have used this mercury in our thermometer. That's the red narrow thing that you are seeing into our thermometer. We also have here our measurements. They are totaling to 100 degrees Celsius. Yes, so you can see the movement of this mercury from its normal to where it will stop. That will give us the boiling point. Yeah, but remember to reset. There are many ways of resetting the mercury. You can reset a mercury to 0 degrees by using the ice cubes. Yeah, remember that ice cube it's liquid, it's water, but it's at the freezing point, which is 0 degrees. So the way you can reset this mercury on 0 degrees by placing it into the ice cubes, such that it can be reset. Yeah. So also you can also reset the mercury by hand shaking, by shaking this mercury. That's another way of resetting it. So as you can see here, our movement of the mercury from where it was to where it is now, it's just rising slowly. Yeah, so as you see, here is our movement of the mercury. So we are going to determine our we're going to determine our measurement of the freezing of the boiling point of water. So as you see here, the water, the movement of its particles, yeah, the water is just boiling because of the source of heat provided. Yeah, so you can see this water is just boiling. When this water boils, this bulb of the thermometer, yeah, which contains some mercury, enables this mercury to raise up due to the increase in temperatures. So you can see here the movement of the mercury. The mercury is just increasing where it was. So you can also see the water particles, or the movement of the water, how the water particles move, meaning that the form or the state they were is now changing, which we can call the water can boil, or the boiling of the water, which can also cause evaporation. So meaning that this water can change from its natural state, which is liquid, to another state, which is gas. So as you see here, the mercury is just increasing, as I told you. So you can also see the movement of the particles in water. Remember, I told you this mercury here has this bulb, the small tiny part, the ending part of it, which is called the bulb. And this bulb contains some mercury, and this bulb, like, it directs, or whenever the temperatures increase, the bulb is able to sense and makes the mercury to increase. So you can see here, it's just 93 degrees Celsius, and as I told you that that the boiling point of water is 100 degrees Celsius. So many people can ask, they ask some questions. They are like, why is it 90 degrees Celsius yet our water is boiling here? And I told you that the boiling point of water is 100 degrees Celsius. So the reason why this water is just stopping at 93 degrees Celsius, not 100, because you can see we have seen it just like for 2 minutes, it's on 93 degrees Celsius. Instead, it would have just raised above and not reaching to, or it would have just raised above and reaching to 100 degrees Celsius. So you may ask yourself, why is it reaching at 90 degrees Celsius yet our water is boiling? So as you can see, if you look closely here at our beaker containing this boiling water, you can see there is some smoke coming out. And this smoke, remember, as I told you, that this water, for it to change from one state to another state, it needs increase in temperature, causing boiling to occur. So when this boiling occurs, some of the processes that will occur, we have some process called evaporation. Now this evaporation causes is the physical state, or the physical form of water from liquid to a gas. So we can see now this water is just there's some steam that is coming out of this water. So as I told you, you can see here clearly it's on 93 degrees Celsius. And why is it not on 100 degrees Celsius? It's not on 100 degrees Celsius because this steam coming out is also determined, or it can also be added as the degree of this boiling of this water. Remember, this temperature, the more the temperatures increase, the more the degrees of the water increase. But for this form, our degrees of the boiling is at 93. Reason being, our water is evaporating, and this evaporation, or the escaping of the steam, is affected by the readings of the mercury, causing it to stop at 93 degrees Celsius. Yeah, so if we had something to cover here, and this steam won't escape, and it would be just trapped in one position, in the same position, this water, or the measurements on our thermometer would have increased to 100. But remember, as I told you, the steam is just escaping from water, causing that can affect the readings by stopping on a certain point, and while the water is boiling. So as you see, I think I've explained why it's on 93 degrees Celsius. It's just it's its constant form. Yeah, so you can see. So that's how our experiment has ended, by determining the boiling point of water. And you have determined the boiling point of water. As I told you, when you are determining the boiling point of water, you need to increase the temperatures, because these temperatures increase. When the more the temperatures increase on a substance, the more the temperature of the substance also increases. Thank you for watching.